But if you are, I am going to get started. Bear with me. This is the first time I'm streaming via this platform. So, all right, hopefully you can see my screen. This is Goland, and today what I'll be working on is adding support for locality optimized search. So what does that mean? Basically, for our multi-region tables, we are going to try to search local regions first before fanning out to the remaining regions. So if you have a query, say select star from table where ID equals 5, you don't happen to know which region ID 5 is located in, we would assume that there's some kind of locality of access patterns in the workload. So we would first check the local region. And assuming that ID is a unique column, if we happen to find it in the local region, we know that ID equals 5 doesn't exist in any of the other regions, so we can just return early. We don't need to bother fanning out to the remaining regions. Okay, so the way we're going to implement that is we first need to give the optimizer information about where each of the different partitions is located. So we don't even give that information to the optimizer today. So what we're going to do is add a function to the catalog. This is kind of the interface that the optimizer uses to get all the information it needs from the rest of the database. So we currently have a couple of relevant things. We currently, oh, I think there's a chat maybe somewhere. Ah, Marcus. Hey, Marcus. I'm not seeing the screen. Toggle switch to light up the screen. It says I'm sharing my screen. Can you hear me? Okay, I can see and hear me, but not my screen. It says that I'm screen sharing. Let's see. Oh, I see. Now that, okay, cool. I get it. All right. Is that better? All right, cool. I'm going to close Slack now, so we don't have any more distractions. All right, cool. Now looks like it's all working. Awesome. Sorry for the technical difficulties. Still figuring out how this all works. So, all right. Hopefully now you can see my Goland. Didn't really miss anything since I was just talking about what we're going to be working on today, which for those of you that missed it is locality optimized search. So basically, the optimizer needs the information about the regions where each of the different partitions is located. So currently, we are giving the optimizer information about the zone, but this zone currently only is set if the entire index has the same zone. So this was relevant, or still will be relevant for tables not using our new multi-region patterns for the duplicated indexes pattern. But so now we need, we don't care just about the zone for the entire index, we care about the zone per partition. So I think what we probably want to do is actually create a new catalog object called partition, because the only thing that we have right now about partitions is this partition by list prefixes, which just is a bunch of datums and doesn't include any information about which partition each of these datums belongs to. So I could put it in this index file. Yeah, well, let's just do that for now. So I'm gonna and partition is going to have a name. I don't know if we actually care about the name yet, but just probably for debugging purposes, it'll be kind of useful. It's going to have a zone config. And it's going to have some datums. I think I might want to change that, but for now, let's just go with that. Okay, and the index is also going to return which partitions it has. So this is going to make all of the current things that implement this no longer implemented, but let me just write this and then I'll comment it out. So partitions, well, all right, so to be consistent with how we do everything in the catalog, I'm going to have a partition count, which returns an int, and then I'm going to have partition I, which returns a partition. Okay, I think that is kind of consistent with how we do things. Yeah, see, like we have these various counts, and then we have functions that take an index and return the object. Okay, so I'm gonna copy these and comment them out until I have implemented them in each of the different things that I care about. So this is our test catalog. And this is a cat.partition that is getting returned. Okay, for now, let's just return some dummy stuff here. And we need to do the same thing for, okay, so this is the one that I'm going to actually fill in for real shortly. The last one is opt virtual index. So this one, virtual indexes don't have partitions as far as I know. So that will probably be fine. Okay, so now I think I should be able to uncomment this and everything should still correctly implement the interface. Okay, so let's try to fill in the this for the opt index. So do we already have this information? Probably not. And we're probably going to want to cache it also and not need to recalculate it each time. But for now, let's just recalculate it each time because I'm just trying to get something working first. So partitioning. I think to start out with, we only care about the list partitions because for multi-region, I'm pretty sure that everything is just going to be list partitions. Basically, we're listing out the different regions that are part of each partition, which is just going to be one region, basically. But I can always change this later. So it's just going to be the number of partitions in this list, I believe. Okay. And then to get the actual partition, this is going to be trickier, I think. Okay. Oh, well, so we need to return something that actually implements all of these different methods. So I'm going to have to make a new struct that implements partition. So there's a lot of stuff in this file already, but it's okay. All right, let's just put it here because okay. And partition is going to implement our three methods. So all right, let's just go back to returning nil for now here. And these are the three methods that I need to implement. Okay. And so we're going to have a name, which we will return here. And the zone. Okay, I'm going to need to figure that out, but for now, let's just return nil and return nil here. Okay, so now we know that partition implements the cat partition. And hopefully my little red squigglies will go away soon once Golan figures out that everything is correct. Okay, yep, all looks good. So now we need to figure out Okay, well, like I said, I'm just going to do all of the computation here and then probably cache it so I don't need to compute it each time we want to get the partition. So so each of these partitions, what do we have in P? Okay, so we have a name. We have subpartition and values. I don't think we care about the subpartition. We can come back to that. Okay, so how are we already getting the partition by list prefixes? I see. Okay, so sorry, this is getting partition I, so we don't need to iterate through all of these things. We just want this one partition. And we want to do something like what is happening here to get the datums. Okay, let's we'll just make a op partition to put all this stuff. So the name, of course, is going to be the name of our partition. Does it want me to put a comma there? Maybe not. No. Okay. Sorry, confusing myself. All right. What is a? And we don't actually want to append to the result because, well, default case where there's nothing to return. I'm not sure even what that means. So we want to store some datums. I guess we want to store a list of datums because in theory, each partition can have multiple different values. So right, and we probably want to allocate this first. I based on the length of values. Okay. I'll leave this to do here because that might be important. So items, partition values. And now we need to get the zone of the partition. So this is just going to return p.datums. And I think I'm just going to rename this because no, actually, I'll just leave it like this for now. Okay, and the zone. So let's find out where we're getting the zone elsewhere in this file. Just get zone config too. Okay, so this is getting the zone config for the entire table. That's not what we want. Okay, this is where we're creating each of the indexes. So this is where we are basically ignoring all of the zones for each partition, and we want to not do that. So I think this is the point maybe where I should just start caching stuff because I want to be able to reuse this code here. So with that, I think this is maybe not the best. So this is going to be partition zone. I really don't know how these zones all fit together, but let's start by just assigning the table zone, and partition zone will inherit from that. And now we're going to I don't think we where do we actually create the index? Oh, I see. Okay. Yeah, let's just, for now, create a map. What is this zone thing? Zone config. And so this is where we're zooming in. And that is going to equal to partition zone. Well, I guess I can just do this. Okay, now I need to pass this to where we initialize the index. Converted. Okay, and it has a zone, and then we'll pass the partition zones. It's a map from string to this thing. And here we pass partition zones. And partition zones. Okay. There we go. Now, okay, I'm going to just store a list of partitions in the index. And let's do it here. So partitions make and I want that to be equal to the length of the descriptor partitioning by list. And okay, so for bench, I'm gonna now copy the stuff that I already did before. And okay, we're not just creating a new thing here because partitions I and then equal op partition, and it has a name which is equal to p without name. It's datums and then the zone is going to come from our zones. And to actually add zone here. Does that work? Cool. All right. We got the name, we got the zone, we got the datums. I think we have everything we need. Okay, so now we need to actually do something with this info that we've given to the optimizer. Just checking the chat. Thanks for the encouragement. No, feel free to ask questions too if there's anything that's not clear. Okay. All right, so let's go back here. We, oh, I think we probably didn't actually implement this method. Yeah, this needs to be fixed because now we are storing these things on the descriptor. So, and we need to return Goland. It's taken a while to think if it's happy. All right, Goland's happy. Cool. So, okay, so now we have this information. And I think what we want to do next is basically write a rule that checks if there are some constrained spans in a constrained scan where some of the spans can be targeted to a particular partition with a specific zone config. Oh, we also need to know what the local region is, which I think we already have that information because we must already have that information for the duplicated indexes pattern. Yeah, okay. This locality came from somewhere, from the eval context. Maybe that's fine. All right, well, let's not worry about that for now. Okay, so I think this is going to have to be an exploration rule because it's going to be operating on constrained scans, which are produced by exploration. So that is going to be we're going to okay, so I think what we probably want to do is build a new operator first called locality optimized scan. So that is going to happen inside relational. And has a scan private. Now, do we want to create a whole new operator, or do we just want to modify the existing scan to possibly make it a locality optimized scan? I think that might be better. Partition constraint scan. This looks potentially useful. I wonder if we can actually use this Boolean for this rule. What is this called? Partition constraint. So for those of you not familiar with the optimizer, I was looking at this .opt file, which is basically just a specification. And then we actually code generate the Go file. So this is the generated file. Well, is this really, just because we have partition filters, does that mean we're actually using them? Not totally sure. Okay, so we only calculate them if our filter columns does not already contain the first index column. So index columns. Okay, so we have basically some of the index columns constrained, but not the first one. Then we want to see if we can actually constrain the index using these partition filters, but also the optional filters. So Where are these filter columns coming from? Oh, okay. No, we already include the optional filters in these filter columns. So we're only calculating the partition filters if we really need to. So we know at this point that at the point when we're assigning this that we did use the partition filters to constrain the scan. Okay. So I wonder if we can easily figure out which partition filter was used. What are okay. I see. So I see. So what's happening here probably is that we are building a multi-span constraint where each span is starting with a different partitioning value. So what we would need to do to make a locality optimized scan is split the scan into two pieces, one where we have the spans for just the local partition and one where we have the spans for all the remaining partitions. And then we would effectively union those together. Oh, and we can only do this when this is only worth doing when we know that we're looking for a unique value, and if we find it in a local partition, we don't need to look elsewhere. So we can do this on scans that we know have cardinality equal to 1, because we should have been able to use functional dependencies to know that we're constraining the key, and therefore it should have cardinality 1. Although the question is, are we even doing that? Yeah, so maybe what we actually want is this new operator, locality optimized search operator, to have its child be two different scans, where one is the local scan, or its children be two different scans. One is the local scan, one is the remote scan. And it would only initiate the remote scan if the local scan turned nothing. Okay, yeah, let's do that. Kind of like a union, I guess, but how are we doing unions? Left and right row expros. Or it's a union all, really. Do we have a separate union all operator? Yeah. Okay. I guess it doesn't technically need to be a scan. I can just call it a locality. Well, whatever. Leave it that name for now. Okay, let's build this. Actually, this will be a good test to see if the other stuff we wrote is actually buildable. Any questions in the meantime? Ah, I see. Just a question. Is it possible to deploy Node.js app on Heroku? This is not a question I know how to answer. I definitely suggest that you check out our community Slack if you're not familiar. Just an optimizer. I'm not trying to understand the question, Rajiv, if you could clarify. But yeah, Devarsh, check out our community Slack. I think there is a link on our website. And definitely ask a question there. Hopefully someone can help you out. All right, we are building. So the reason I started to build is because, well, first of all, this will check that all of the code I already wrote compiles, but also it will generate the optimizer file. So I just added that specification for a new relational operator, the locality optimized scan, and we have to generate the Go code that will create a struct for that scan, for that operator. It's taking its sweet time. Oh, I see. Not a question, just for the naming part. So yeah, so this whole thing that I'm working on is the optimizer. So it wouldn't necessarily make sense to name just a part of this the optimizer. But yeah, thanks for engaging. And any questions, feel free to write in the chat. All right, looks like we got some errors. Build locality optimized scan props undefined. And build locality optimized, yeah, okay. So we're gonna need to write this method. Where is this? In logical props builder. My two different things, computer science, invalid and cache and naming variables. Agreed. All right, let's see. So we can put this just right under build scan props. And what do these functions take? I wonder if this thing actually got built. Oh yeah, there it is. Locality optimized scan. Expert. And we get relational properties passed in. Okay, I think I probably want to do most of this stuff later, but well, just to get something down. So the output columns are going to come from our two inputs. Although actually the two inputs, it's basically a union, so it should be exactly the same as the local inputs. So optimize scan dot local dot output calls. And actually, we really should be able to just copy all of the properties from, well, no, that's not true. This is interesting. So for the not null columns, it's going to come from both sides, and we basically want the intersection. I don't like this name. Speaking of choosing names. All right. Dot relational calls intersection with remote. Okay. Outer columns, it's not going to have any outer columns, I don't think. Functional dependencies. Yeah, we should This is really the same as a union all, so let me just find how we are doing that. Yeah, so this is kind of doing an intersection, but it's tricky because, oh, that's a good question. Are we gonna need different column IDs for the local and remote scan? Probably. I wonder if it would be better. I wonder if it would be better to just represent this as a union all, and then we can just reuse everything from the union all. But we would need yeah, maybe this should be a union all and we should just add it to the set private. Well, that feels kind of ugly. Or, well, no, maybe it should still be its own thing. Maybe it is just like a set operator, but it's its own operator, but it inherits everything from all of the different set operators. So, okay, let's go back to our union all. Yeah, so we can add this tag to make it a set operator, and it's going to have a set private and everything. And we can just kind of do everything that the union all does, but because it's a locality optimized operator, we know that the left input is local and the right input is remote. So let's go back to our locality optimized scan. Just going to move this down to union all. Set. And it is going to have a set private. Okay, now, good thing is we can just kind of get rid of all this. And put it here. And we're just going to build set props. All right, looks like we're pretty much out of time. So I'm going to wrap up here. But looking at a white theme IDE. Yeah, I'm not into the dark theme of the IDEs. I prefer the light theme. But all right, thank you all for joining, and I will be back in a couple of weeks. Have a good day.